In this segment, I'm going to demonstrate a simple circuit design using Tinkercad. This is a wonderful simulation site, tinkercad.com. And when you go over there, you can create an account. It's free, and then you can go and build circuits. I'm going to show you now how, once you have logged in, how you create a circuit, especially using Arduinos. So this button here will allow me to specify a new circuit creation. I can go over here and select Arduino from the list. There are already a bunch of designs that are available to you, some very basic designs. And I'm going to take one that is already ready-made and stick it over here. I'm going to put it right here. As a matter of fact, using the mouse wheel, I can make it bigger or smaller as I like. Now, I can also modify this, and I'll do it just to show you how you do it. I can go to the components and get a breadboard. Here's a small breadboard will do. I don't need a very big one. So I'm going to put this over here, and then I will take this LED and I will move it over here. I'm going to take this wire and move it right here. I'm going to take this resistor and stick it over here. And I have just modified the circuit some to use a breadboard. Now notice that the LED is connected on two different channels. Remember that this is a channel that is all sorted like this behind the plastic, and so is this. So this end of the LED is connected to this wire, which is then connected to the ground of the Arduino board, and then the other end is connected to one end of the resistor, and then the other end of the resistor is connected over here to a pin, the pin D13 of the Arduino board. That means a digital pin number 13. Now, one other thing you need to notice is I put the resistor over here like this. I did not go and place it like this. It would be no point connecting it like this, because all of these behind, all of the holes behind here, they're shorted together. So this end and this end then would be shorted together. So whether you have a resistor there or not, then it would not matter. So you would have to either put the resistor like this from here to there, okay, like that, in that kind of arrangement, so that the two leads are on different channels, or you can go and do what I did before and just place it like this, because this channel and this channel down here, they're not connected. All right, so enough with that. Let's go and look at the code. If you click on this button, you're going to see the code that is programmed into the Arduino in this ready-made circuit. Now, the way the code appears over here is in a visual form, and you do have the luxury of doing that, and you're welcome to go over it if it suits you. However, what we're going to do is we're actually going to go for the text mode of the code. So this is a very basic code that is C-like for the Arduino. And let's go over the anatomy of it. First of all, this part over here is a comment. Anything that starts with this sequence of characters, it is a comment, and it will continue being comment mode until you get to a closing sequence for the comment. Right, so all of this is doing nothing. It's not code. You can type whatever you want in there. It's only for our use, and make sure that we communicate something about the code to whoever else might be reading it. But the machine, the microcontroller, the Arduino, is going to completely disregard whatever is in between these two sequences, this one and this one. Then you need a block of code in which you're setting up your microcontroller. The standard way of doing it is by specifying a function. This is a standard way that you specify a function. And the brackets that you see over here, the opening and closing brackets, specify the body of code that belongs to that function. All right, this is another function that indicates a loop. This indicates what will keep happening as long as this program runs. Again, opening and closing brackets indicate the block of code that belongs to this function. Now let's go back to this one. This has only one statement, and that statement basically says that the pin mode for pin 13 is output. So it says, in other words, that pin 13 will be used as output. It will be used to be outputting signals. Another option that you have is to designate a pin as input, in which case you will be reading external values that come from external hardware into your microcontroller. In this particular case, we do not have any inputs. There is nothing to read from outside. The only thing that we have is an LED to which we have to provide a signal. So we're going to be using the pin 13, which is over here, it's over here, okay, the pin 13. We're going to be using it as output to output a signal for the LED. All of the signals of this board are going to be either ground, 0 volts, or 5 volts. The Arduino is usually connected through a USB connector to a computer which supplies it with 5 volts. It also loads the program to the Arduino. So whenever you build a program, it is loaded onto the Arduino by the computer. So when you run the program, if it generates any output that normally would display on the computer screen, you can actually see it over here in what is called over here serial monitor on this simulator. All right, but we're not going to have any of that, so we get rid of it. And so far, what we've done is we have we've designated pin number 13 as output. Within the loop function, which is what is going to keep executing as long as the Arduino is running, all right, what's going to happen? First of all, this one is again a comment. The difference between this one and this one is that this one indicates a comment to the end of the line. So this one specifies that from here to here, I have a comment, and it does not have to be terminated. It's terminated by the new line that's at the end of this line, okay? Whereas this one indicates that until this sequence is closed, everything should be disregarded as not being code and being just comments. All right, so this is a comment too, but just a comment to the end of the line. So this statement over here indicates that the controller should output a high signal, 5 volts in this case, to pin 13. So you see the command is digital write, and then the pin number and the value that you want to write to the pin. As you see over here, this is done again. Okay, this digital write is invoked again to output to pin number 13 a low level signal, which means a 0. Okay? In between the time that we outputted the high value and the time that we outputted the low value, there is a delay. Now this one is a function, hence the parenthesis over here, and the parameter that it takes is how many milliseconds you want this to last. In this case, we have 1000 milliseconds, which makes 1 second. The unit that it expects is a millisecond. So then, when the delay is over, the signal is turned to low, so pin number 13 will be carrying a low signal, and then there will be another delay, and then this is going to loop again with this output pin going from 0 volts to 5 volts in sequence. So let's start the simulation, run this code, in other words. This is how you run this code. So we'll start the simulation, and you see what happens. By starting the simulation, you see now the LED over here keeps blinking. 1 second is on, 1 second is off, exactly because of this loop over here. So it is as simple as that. I can stop the simulation here, and this demonstrates a very basic circuit and a very basic program with the Arduino. Anything that you would like to do basically is done using a structure like this. But now let me show you something a little bit more complicated. So I'm going to tinker another design that I have here. And this one has an LED again. It is connected in a little bit different way over here on this board. And now I also have a switch. So I have also input as opposed to just output. But let me go over this and explain it first. So pin number 12, digital pin 12, is connected to the one side of the LED. It's this side, the one that's kind of slanted, as you see, is called the anode. The other one, the straight one, is the cathode. Now the LED has a certain polarity and has to be connected in a certain way in order for it to work. If the polarity is not right, then it does not work. Also, an LED always needs to be in series with a resistor, always. If you do not put a resistor of any value in series with an LED, you're going to burn it. The reason is that the LED, once it lights up, it has almost negligible resistance. For all practical purposes, its resistance is 0. And so the current that goes through it is limitless, and so it burns it. That's why you need to really put it in series with an LED, with a resistor or some load in any case. Now, notice that the way this board is wired, this channel over here is connected with a wire to this channel, and this channel is connected with a wire to this channel. That way, these channels can be used interchangeably. So the negatively labeled channel over here and this one, they are basically the same thing. You can use them interchangeably. Same thing with the positively labeled channels. Now on this end, as you see, there's a wire that connects the negative channel to a ground input of the Arduino. Okay, to a ground input of the Arduino. This is a ground right here. Now there's more than one ground. There's another ground over here, and so you could have connected it over there too. This pin over here outputs a 5 volts straight from the power supply that is supplied to the Arduino board. So this one is 5 volts and it is connected through a wire to this channel. So now 5 volts are fed to this channel and to this channel, and a ground is fed to this channel and this channel. Now notice the LED is connected through this little channel here to the resistor, and then through the resistor to the ground. Once you inject 5 volts over here, this will light up. So that's what this pin is going to do. The pin 12 is going to inject 5 volts once we turn it high to light up the LED. All right. On the other end over here, we have a switch. This one is a push button switch. And once you click the button, then these two leads that are connected to this channel, they get shorted internally to the other two leads. All right, so when the button is not pressed, these two sides, this channel and this channel over here, they're not connected, they're totally disconnected. But once you press the button, then they're shorted together and they're now connected. All right, a few more observations. We have power going from this channel to this channel. So when you press this button, this power is going to be injected onto this channel. Okay, and so it will be injected to this pin, which is the digital pin number 2. Okay, so we press this button, 5 volts from here will flow through this wire to this input. So this will be a way to detect that the button has been pressed. You don't press the button, then this power is not connected here. You press the button, then this power is connected here. Now, let me explain what this resistor is doing over here. This resistor makes certain to drain any residual charge from this wire to the ground. Okay, so when this button is not pressed and power is not injected into this wire, this resistor makes certain that this wire is connected to the ground. So this pin will be reading 0 volts. Without this resistor, this pin would not be reading 0 volts. Definitely when you press the button, it will be reading 5 volts because 5 volts will be injected from this wire to this wire. But when the button is not pressed, this wire would be floating without this resistor. All right, so if this resistor wasn't there, then this wire would be floating, meaning that it wouldn't be 5 volts, but then it wouldn't be 0 volts either. It would be totally undefined. There would be no voltage to it. The voltage to it would be random if you wish. By putting this resistor over here, we make sure that this pin through this wire and then this resistor is seeing 0 volts. When this wire is connected to this pin, when the button is pressed, then 5 volts is injected over here. Current will flow through the resistor to the ground because of these 5 volts. So if you have 5 volts right here, current will go through the resistor into the ground. But it will also flow through here and provide those 5 volts to this pin. Okay, so the purpose of the resistor is to drain this line to the ground if this pin is not connected to this one, and when this pin is connected to this one, this resistor is making sure to protect the source of the voltage, okay, to protect the power supply, because you do not want to connect 5 volts straight to the ground, because then you will be shorting your power source. And yes, that would mean damage in most cases. You'd be lucky not to damage something if you do that. All right, so after we have explained the connectivity over here, let's look at the code. And let me go over the code. First of all, this statement here, defines a variable called OOPS. The type of this variable is Boolean, so its value would always be either true or false, and nothing except of those two values. And in this particular case, it's defined as false. So this declares the variable, that this is a variable that we're going to be using, that's going to be of type Boolean, and its initial value is going to be false. Now that value could be changed later, okay, in the program, but initially is defined as false. This word, this keyword volatile, means that this is a persistent variable that can be used throughout the program, okay, with changes to it sustained. This one is another declaration that declares another variable, the variable count, okay. It declares it as integer, and its initial value is going to be 5. This does the exact same thing. It declares another variable, name x, and its initial value is going to be 0. Like before, we have a setup routine. We have a setup function, a segment where we do setting of our pins. This one indicates that the pin number 2 will be used in input mode. The pin number 12 will be used in output mode. And we're also going to start a communication with our terminal. In this case, we're going to be using this serial monitor. So this statement is to begin a serial communication with the terminal, where you get stuff displayed. That is the computer that is connected to the Arduino. And in this simulator, it is simulated by this area that's called serial monitor. All right, here is the function that is going to be the loop. That's going to be what's going to keep executing while the Arduino is on. All of these lines here, they're commented out, therefore they have no effect. It's as if they do not exist, and we can remove them altogether. So the loop over here is just this body, and what happens is the variable x assumes its value by reading the digital pin number 2. So this statement, when executes, the pin number 2 will be read for a value. Since it is digital, the value is going to be either a 0 or a 1. In other words, it's going to be either true or false, with true meaning 1 or 5 volts, and false meaning 0 or 0 volts. Then the program will cause this message, which is in quotes, to be printed to the serial output, which is going to be the terminal. So this is what we call a string. It is included in quotes and it's called a string. So simply this is just text that is going to be printed out. Then it's going to print the value of X. The difference between serial print and serial print ln is in this ln, which means line, which means that after whatever you have in the parentheses is going to be printed, a new line is going to be inserted in the end. So there's going to be a change of line. I will explain in a moment. This one is an if statement that contains a condition and then a block, in which case it's just one statement, but it could be a whole block of statements that is going to be executed if this condition succeeds, or as we say, if the condition is true, it evaluates to true. Otherwise, it is going to execute the other block, which is after the else. And then there's going to be a delay of 1000 milliseconds, 1 second in other words. This is a comment starting from this sequence to the end of the line. It's a comment. All right, so in other words, we're going to read the digital input 2, which is this one. We're going to print what we got, and then if the value is high, 5 volts, in other words, if this button is pressed, then the Arduino is going to write to its pin 12 a high value, i.e. it's going to output 5 volts on pin 12. Otherwise, it is going to output a low, that is 0 volts to pin 12. And then there's going to be a delay, and then all of this is going to keep repeating until you break off the program or cut off the power to the Arduino. Okay, so let's see it in action. First of all, let's open the serial monitor so that we'll be seeing what these statements are printing, and then we're going to start the simulation. As you see, I'm going to stop the simulation. As you see, we're getting the statements from here. So value X is printed, and then the actual value X is printed, and then a new line. So we go from here to a new line every time after the value of X is printed, that is. And then with a delay of 1 second, it's going to keep repeating. So as long as nothing's happening over here, on pin 2, what the Arduino is reading is a voltage of 0 volts, because with this not being pressed, this one drains to the ground through the resistor. So what it has over here is 0 volts. Okay, now let's clear and start again. Now this time, look what happens when I press the button. When I press the button, the value X is 1. You see, over here is 1. And the LED turns on. See? press it again, LED turns on. When I release the button, it turns off. Press it again, turns on. Release it, turns off. Press it again, and then turns off. Okay, that's how this thing works. And stopping the simulation, and that is the end of it. Feel free to make this and play around with it yourselves.